Okay, welcome back to part 2 of the video. On number 6, they've already shown you the graph of the video and are just asking you for the zeros. So all you're going to have to do is look on the graph and write down the 2 zeros. On number 7, easiest way to do this is to put it into your graphing calculator and graph it and find the 2 zeros looking at your graph, or sketch it, or make a table. It's up to you. So pause your video to do the answers for 6 and 7. And then start it back up to check your answers. Okay, so just make sure that you got the same answers or same zeros. On number 8, 9, and 10, it's asking you to approximate. Approximate. You're not getting the exact, you're getting really close, you're estimating. So you're going to look and see that on number 8, our first zero is here between the 0 and 1. And when I'm looking at it, I say, okay, you know what? This one looks like it's going through, it's a little less than halfway. So I'm going to say x is approximately, so I'm going to use my little approximately sign, x is approximately 0.4. Now you might have looked at it and said, no, that's definitely 0.3. These are approximations, so it's really a little bit of an individual call. And then when I look at my second zero, I can see that it's between 2 and 3. And in my mind, it's a little past halfway, a little bigger than halfway, so I'm going to say x is approximately 2.6. So that's how you approximate. How can you use this? When you're on a test, you can look and say, well, it's approximately these numbers. A lot of times, if it's multiple choice, you can get to your answer just using approximation. Also, if you come up with an answer doing another method, you can look and see, am I right? Am I in the proximate area or not? So it helps you check reasonableness. So I want you to pause your video and do number 9 and 10 on your own, and then check back for the explanation. Okay, since we were approximating, you may not have come to the exact same answer I did. You may be 1/10 one direction or the other on any of these, as long as we're very close in the same ballpark. Now, for number 11, this is a real-life situation of a football being kicked into the air. So it goes up, it comes back down. What I want you to do is to find the height of that football each second after it's kicked. So it's kicked at 0 seconds. So you're going to find how high it is at 1 second, 2 seconds, 3 seconds. Just go up to 4 seconds. And then I want you to estimate when the height of the football is 50 feet. As a hint, it'll be at 50 feet twice, on the way up and on the way down. So I want you to go ahead and do the work on number 11. Pause your video while you're doing it, and then check back for the explanation. Okay, so just looking at the table, you can see the height of the football as it's going up, and then it looks like it's turned around and it's going back down. So I just went ahead and drew a line, because this is my height. So if I'm looking for 50 feet, I can see that it passed up through 50 feet right here, right before it got to 1 second. So a little bit before 1 second, it was passing through 50 feet. And then it goes on up and comes back down. And here at 4 seconds, it's 46 feet. So right before we got to 4 seconds, so 3.8 seconds or something in there, it also was at 50 feet. So that's how we use estimation and information to give predictions. Okay, on number 12, this one's actually wanting you to use the graphing calculator, putting it into stat edit, and then stat calculate with 5, which is the quadratic regression. And you know this because it wants a quadratic model. So you're going to put this data into your graphing calculator. But the thing is, this is written on a 12-hour clock, but we're talking about hours after midnight. So if you think about this, this is 6 hours after midnight, 8, 10, and 12 hours after midnight. But right here at 2 p.m., that's 14 hours after midnight. Then we have 16 hours and 18 hours. So I just wanted to remind you that when you're setting up your table in StatEdit, your X values are going to be going 6, 8, 10, 12, 14, 16, and 18, and that's how come. Okay, so go ahead and put it into StatEdit, calculate the quadratic equation, and then you will put that in your calculator and pull up the table to estimate when it is 64 degrees, and it'll be 64 degrees at 2 different times. So pause your video while you're doing this and then check back for the final explanation. Okay, so when I put in the data that they gave me into my calculator to get a regression model, it gave me this equation right here. I did go ahead and round my decimals to just 2 decimal places, and then I put that into my calculator to get their table. And when I pulled up the table, I'm just putting my modeled data down here. I didn't put all the hours, but I put some of the important hours. So if you kind of look, our modeled data is just a little bit different, but not too much from the actual data. And then the question was, at what times of the day is the temperature 64? Well, we can look and see exactly at 4 p.m. it said 64. But if I'm using, and I can also look here between 10 and 12, it looks like sometime probably right at 11 it's 64. But if I use my modeled data, then it also was right after 11, 63.6 at 11 o'clock. So right after it, it's going to be 64 degrees. And then it's coming back down at 4 o'clock. It's just a little above 64, so just right after 4 o'clock are the two answers.